This is part 2 of the rate and equilibrium topic in GCSE AQA chemistry. It's a dual and triple award topic, so all students will need to be able to cover this. In this particular video, we're going to look at collision theory and surface area and the impact of changing surface area on the rate of a chemical reaction. So, knowing what factors affect the rate of reaction, explaining the principles using collision theory, which we will come back to repeatedly across these videos, and specifically use collision theory to explain how surface area impacts on reaction rate. Now, across the course of the next few videos, we will be looking at each of the factors that are listed here. If I increase temperature, surface area, concentration, or pressure of a reactant, then I will increase the rate of reaction. Similarly, if I use a catalyst, that will increase the rate of reaction. Now, we need to know what collision theory is. And we need to remember it in a very simple way. For a chemical reaction to take place, particles must collide with each other. But actually they have to collide with enough energy that they won't just bounce back off each other, they will collide with sufficient intensity that that collision will result in a reaction. It's actually true to say that the vast majority of collisions do not result in a reaction. But by changing the factors that I've just discussed, we can increase the frequency of collisions and therefore successful collisions. Going to start off with a very simple model here of how changing the surface area of something can change the rate at which things happen. And I've got roast potatoes on the left and I've got fries on the right. Which of these is going to cook faster and why? And you've hopefully answered there that the fries will cook faster. And that's because they have got more surface. If I've got 3 potatoes and I cut them into 10, 11 chunks, or I cut them into dozens and dozens of little chips, there's far more surface area on those chips for the same mass of potato. And the oil that causes them to crisp and to brown and to cook, there's much more surface exposed to absorb that hot oil. So it all takes place much more quickly. Now let's move that to chemistry and look at an example of rusting of iron nails. Which would you expect to rust faster? An equal mass of the large iron nails on the left or the small iron nails on the right? Again, I'm going to point out an equal mass. We are looking at that as a control variable. And we would say that the small nails will rust faster. Why? Well, there's a greater surface area of them exposed to the water that will cause them to rust. Some calculations now. Have a read through this and then try. So we have got group of students and they were reacting marble chips and they were seeing how long it took, taking 5 grams of marble chips, reacting them and seeing how long it took for the reaction to stop. So essentially, how long for 5 grams of marble chips to react? And we had large chips, medium chips and small chips. Calculate the mean rate of reaction. Now, in the previous video, we looked at mean rate of reaction and also specific rate of reaction at a specific time. Mean is the overall rate. So I've got my mass, 5 grams, divided by the time it took. 5 over 294, 5 over 188, 5 over 102. Let's actually do those calculations and we can see 0.017 grams per centimetre per second, 0.027 grams per second and 0.049 grams per second. So what do we notice about the rate as the chips get smaller? It's gone from 0.017 to 0.049. The rate increases as the chips get smaller. What does this mean is happening to the rate as the surface area increases? Well, we've spoken about the size of the particles, but let's actually think about what that means in real terms. If I've got a sample here and I cut it up into smaller pieces, all of these shaded bits here are now exposed when they previously weren't. So as I go to smaller pieces, the surface area increases. So rate increases as surface area increases. What control variables did we have here? Well, we had the same mass of materials and we used the same materials to react. As a practical, there are many different ways you can measure rate of reaction. Take the time to read through this one. There are some questions that will follow in a second. But once again, we're looking at the reaction between marble chips and hydrochloric acid. You can see we're using a gas syringe, and a gas syringe is a great way of measuring the volume of a gas produced. This is sealed, so any gas made will move up and it will force the plunger out. So we're taking 1 gram of marble chips, we're reacting it with 25 centimetre cubed of hydrochloric acid. And we're seeing how long it takes to produce 50 centimetre cubed of gas. Then we do it all over again, but instead of using the marble chips, we use crushed up marble chips. Now, one thing that you might be expected to do is design a results table. How would you design a results table for this? Let's take a look. I'm going to put one together here. I think the important thing whenever you're designing a table is keep it simple. We want to know the time taken to produce 50 centimetre cubed of gas. That's the dependent variable. It's the thing we're measuring as a result of changing the independent variable. I'm still not quite there though. I've missed the units. So I need to say that we're measuring that in seconds. What am I going to put at the top? Well, we're doing marble chips and crushed marble chips. There are no units for that. They are descriptive headings, but they are the independent variable. They are the things we are choosing to change. And in any results table that you ever design, what we're going to be looking for is that you have got the independent variable and the dependent variable within your table with all appropriate units. Now I'm going to provide you with some data here that we can use later on. The marble chips took 43 seconds. The crushed marble chips only took 14 seconds to make 50 centimetre cubed of gas. Some questions. What type of marble has the highest surface area? Well, we've spoken about this already actually. Smaller chips have a larger surface area overall. And remember that we were using 1 gram, whether it was marble chips or crushed. So the mass of the marble was a control variable, so there is much more surface area exposed for the same mass. What does this experiment tell us about the impact of increasing surface area on the rate of reaction? Again, this isn't new information, but we're reinforcing it. Increasing surface area increases the rate of reaction. We can actually go further and say that doubling surface area doubles the rate of reaction. More on that later. And can we explain this impact using collision theory? Well, we spoke about the fact that in collision theory, particles must collide so that they can react, but they must collide with energy equal to or greater than the activation energy. If I increase the surface area, I am increasing, and there's a good key word here, I'm increasing the frequency of collisions. And if I increase the frequency of collisions, I'm also going to increase the frequency of successful collisions. That is, collisions with sufficient energy to result in a reaction. Finally, we're going to look at a couple of calculations, and I've brought that data forward again. Calculate the mean rate of reaction. Remember, there are 2 ways of working out rate of reaction. It can be the mean, or it can be at a specific point drawing a tangent. Here, we want the mean rate of reaction. Try the calculations out. So for the marble chips, it is 50 centimetre cubed took 43 seconds. So that's 1.16 centimetres cubed per second. And for the crushed marble chips, it took 14 seconds. So you can see the rate is higher, 3.57 centimetre cubed per second. That takes us to the end of this video. Thank you for listening and goodbye.